Lesson 12.1 is going to move into probability, and we're going to start with counting principles and independent events. Now, independent events are when the outcome of one event does not affect another event. So they really just exist on their own. No matter what happens to event A, event B is going to happen at its own same probability. So there's a couple of ways that we can do this. The first way we are going to do is we are going to use a tree diagram to figure out how many choices are available from this sandwich menu. We have a choice of white, wheat, or rye breads, and we have choices of butter, mustard, or mayonnaise. How many choices are possible is what we are answering. So when I go to make a tree diagram, I have white bread, I have wheat bread, and I have rye bread. Now it doesn't matter if I choose white bread, then what spreads I can have on it, so these truly are independent events. So if I pick white bread, then I have my choices of butter, mustard, or mayo. If I choose wheat, I still have those same three choices, and if I choose rye, I still have those same three choices. And if you count up what happens here, 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 at each of these ends, you see that we really have 9 choices. I could have white with butter, white with mayo, mustard, white with mayo. Same down the line with wheat and rye. So there are really 9 choices when you count them up. But if my tree diagram, if I have more options than this, I'm not sure I want to draw a tree diagram. So what other choices could I have? Now the fundamental counting principle is that other choice. And this says for independent events, you multiply the number of choices for each event. So if we think about going back here, to use the fundamental counting principle, we had 3 bread choices and we had 3 spread choices, and that also gave us 9 choices. So we know it works. So what is this? The Murray family is choosing a trip to the beach or to the mountains. 2 choices on location. They're going to get there by car, plane, or train. 3 choices for transportation. How many different ways? And that is 6. So if you were to do a tree diagram, beach, mountains, car, plane, train, car, plane, train, you see that we still end up with 6 choices, just that the fundamental counting principle makes it a little simpler. Now what happens if we have more than 2 independent events? How many codes are possible if the code is just 2 digits? So we have a 2-digit code, and if we can allow repeats, that means in here I could put digits 0 through 9, which means there are 10 digits, 10 choices. In this one, if it's truly independent, meaning there can be repeats, then there are still 0 through 9 to choose from, which gives me another 10 choices. By fundamental counting principle, that means there are 100 combinations. 100 different combos of 2 numbers. What would happen if it were 3 digits? Well, a 3-digit number, if they are truly independent, I can pick from 0 through 9 for each of the 3 digits. That means there are 10 choices for each of the 3 digits, means there are 1,000 combinations of numbers. Now these are independent events, which means we can have repeat digits. Now if we think about dependent events, where the outcome of one affects the other, or others, as the case may be. So Charlita wants to take 6 different classes. So class A, B, C, D, E, and F. Those are her choices. Assuming each class is offered each period, how many different schedules could she have? So in her first hour slot, she still has all 6 classes to choose from. Oops. So she's going to pick A. That one's off. Now she only has 5 to choose from. She's going to put C in that slot. Now she's down to 4 choices. She might pick E. When she goes to her list, she only has 3 choices left. She's going to put F in this slot, and she picked that from 3. She has 2 choices left, B and D. So she's going to pick B, and then she was left with D. So each time she made a choice, she had fewer options because it depended on her previous choice. We still can multiply all these things up, and we come up with 720 schedules. Because each time you would flip one class with another, it becomes a new schedule. Well, this actually is an operation, and it's called factorial. And that's the operation, and the sign for it is an exclamation point. So if you say 6 factorial, that really means take 6 times 5 times 4 times 3 times 2 times 1. If you take 4 factorial, it means take 4 times 3 times 2 times 1. And there is a button for that on your calculator, and it's an operation just like addition or subtraction. And that is another way to do dependent events where you have one less option each time. That is the end of the 12.1 lesson.